Have you ever wondered what keeps heavy industrial machines running smoothly for thousands of hours? The answer lies in a small but mighty metal alloy called Babbitt. Today we'll uncover the fascinating story of how this little-known alloy quietly revolutionized mechanical engineering. Back in 1839, an American inventor named Isaac Babbitt created a special alloy that quickly became the gold standard for bearing linings in engines, turbines, and industrial machinery. What made Babbitt so special? It was its ability to slide. Unlike hard metals, Babbitt is soft and adaptable. It conforms to the rotating shaft, reducing friction and preventing damage. A true game-changer in its time. The original Babbitt alloy consisted of 89% tin as a soft base, 7.5% antimony for added hardness, and 3.5% copper to increase load-bearing strength. This carefully balanced mix created a material that wasn't just durable, it was also sacrificial, wearing down to protect more expensive components. Later, more affordable versions using lead instead of tin were developed for less demanding applications. Making Babbitt isn't just about melting metal together. It requires precision. First, tin or lead is melted in a crucible at temperatures ranging from 200 to 480 degrees Celsius. Once molten, antimony and copper are added in exact amounts. The mixture must be stirred continuously to avoid separation, which would ruin the alloy's consistency. The liquid Babbitt is then poured into molds or cast directly into bearing shells made of steel or cast iron. Before casting, the bearing surface is coated with a thin layer of tin, a process known as tinning, to ensure a strong bond. After cooling, the bearing is machined to precision for a smooth finish. Some bearings are also grooved to hold lubricants better, enhancing performance. What really sets Babbitt apart is its ability to forgive. It can embed tiny particles of dirt without scratching the shaft, serving as a sacrificial layer to protect vital components. And when it wears down, you simply pour on a new layer. Re-Babbitting. It's fast, cost-effective, and highly practical. Before Babbitt, bearings were made of hard metals like bronze, which caused friction and wore out quickly. Thanks to Babbitt, steam engines, locomotives, and later early cars ran more smoothly with lower maintenance costs. This little alloy played a big role in industrialization throughout the 19th and 20th centuries. Today, while ball bearings and composite materials dominate, Babbitt still has a place in the modern world. It's used in hydropower turbines, heavy industrial machines, and even in restoring vintage equipment. It may seem like a small invention, but Babbitt has made a huge contribution to the modern mechanical world. It's the beauty of time mechanic, where engineering meets history. Is there another mechanical invention you'd like us to explore? Let us know in the comments, and don't forget to like, subscribe, and hit the bell so you won't miss the next story from Time Mechanic.